so I just want to make sure we know where we can find that. There's 2 places, or 3 places really. If you did the packet pickup, you should have gotten 2 different packets for Module 2. If you didn't, I'll show you what those packets should look like. If you didn't get 2 different packets, you can still get the assignment. This is where you're going to submit the assignment anyway. So just like we have been, we're now on Module 2. We've been working on 2.1 the last 2 days. We're going to finish it today. So this is where you're going to submit it. It's due Monday night by midnight. So I'll remind you again on Monday. But that'll be due on Monday. And then what you would be looking for if you got the packets. The packet that you have now is different than the homework packet for Module 2. There was a notes packet. That's the one that we've been working out of the last couple of days. But you also have one called, and I'll pull it up. It's the, I think it says Ready, Set, Go packet. It'll say this on it. If it'll open. So it's going to say this. So this is where all the homework will come out of. So if you don't have a printer and you have the packets, you would just be getting a packet. If you did not get the packet, so this is not something that you have, then here you go, it's right here. And then I think it's probably even easier if you don't have the full packet. I'll post these up individually every day, so you don't have to print a whole packet. But right here would be the homework that you're going to get for tonight. All right, and it's 1 through 12 in that first section. Okay, for 2.1. If you have any issues with this, if you forget about all this over the weekend, reach out to me so that you can find that, and then just try to have that done by Monday. Okay, so then we are going to hopefully finish this up today. So go to the notes from yesterday. We did A and B, and we stopped with the C and the D. We're just going to do one more of these. So we're probably just going to do letter C. I'll leave you letter D because I want to make sure we get to the next page so we can see how to do those next set of problems. So real quick, let's see what we remember in a span of 24 hours. The original equation that we always talk about as our parent graph is this y equals x squared. It has a vertex of 0, 0. It opens upwards, all that jazz. What I want you to now do, see if we remember all of this, is if this is our new equation, tell me the transformations that have occurred. And in this case, you should be able to write 4 different things that we have done to this original graph up here. Just wrong thing. So tell me all 4 things that we did to the original graph in order to create the new equation. Let's see if we remember all this. This is what we basically have done the last 2 days. Okay, let's see here. I'm going to go with Paige. How are you today, Paige?
Good, how are you?
I am good. Give me one of those things, Paige. What's one thing that you can look at that equation and determine has happened to the original graph?
It shifts right 1.
Good. So one thing that she put is it shifts right 1. And we get that from right here. The fact that we have a -1 means we went right 1. All right. Abigail, give me another one. Is it Abby, right? All right, what's another one?
+3.
Good. So this little +3, Abby gets that to meaning that we shift up 3. Good. Let's see here. We'll go. Natalie, you got another one? They're getting a little trickier. You think you have one?
It opens downward.
Good. We know that one's going to open downwards because of this little negative sign. And then the fourth one fourth one was the same one last period is the last one we got to. We probably didn't know the best. Anyone remember what happens for the fourth thing? It has to do with this half here. Oops. Alexis?
I just said that there was a negative 1/2 in front of the parentheses.
Okay, so there's two elements to that. You said two words, right? Negative, half. The negative, because they both do something, the negative gives us this idea that we're going to open downwards. The half does something in and of itself. So the half also does something to our parabola. This is actually what we did 2 days ago. All right, we didn't really talk too much about this yesterday. But remember how we talked about the A is the number in front, and if it falls between 0 and 1, it did something to our parabola. And we talked about how it either makes it wider or it squeezed it, it compressed it. So if it's smaller than 1, if it's in between here, what that did is it makes our parabola wider. For a lot of people, it's kind of the opposite of what you might think. It gets smaller in terms of the A value, but making it smaller actually makes our parabola look bigger. It becomes a wider parabola, okay? So those are all four things that we've talked about. So it's a nice one to kind of do right now as a little review of the last couple of days that we've been doing in class. All right, next thing then. Tell me the vertex, tell me the direction, and see if you remember the axis of symmetry, how we did that. You can't mess up the direction. All right, let's see here. Jake, what do you think for our vertex, Jake?
In parentheses 1, 3.
Good. We went right 1, so if we were at 0 and go right 1, we're at a positive 1. And if we went up 3, then we're going to be at a positive 3. So that's our vertex. Direction, no need to talk about that one. We've already talked about it earlier. This opens downwards. So as a quick little sketch here, 1, 3 is the vertex that Jake said that we are at. We know this opens downwards. So when we go to identify our axis of symmetry, the axis of symmetry is that line that cuts our parabola directly in half. It's a vertical line, so if you remember we talked yesterday about how equations of vertical lines are always x set equal to some number. So our axis of symmetry is x equals, and then we just want to know what x value is that line being drawn through. So if we just look at the red line as it comes down through, the x value that we're passing through down here had to have been this 1. So our axis of symmetry would have said it's just x equals 1. All right. Domain, how far left and right do we go? I think we're good there. I won't ask you to do that. But I do want you to try the range real quick. So now tell me what you think the range would be. The lowest y value to the highest y value. And then I just want to see if we can write this correctly. All right, anybody think they got this one? Jake, go ahead, bud.
It would be -8, comma 3 in brackets. I mean negative infinity. My bad.
Okay, I was wondering where you get the 8 from. All right, -8, and then what?
Comma 3 in brackets.
Good. That's how we want to write that. The lowest point, there really isn't one. We go down forever. So that's why he writes his lowest y value is the negative infinity. And then our highest point is the vertex, and that has a value of 3. So that's got to be the end of that interval. All right? Good. So that's a little review of what we did yesterday, the day before. If you want to finish D at some point, you're bored over the weekend, feel free, but we are going to move along. All right, because I want you to see these next set of problems. So go down to the next couple problems here. And similar stuff, we're going to add the graph of this now. I want you to graph these. So in terms of transformations, if I ask you to do transformations here, I think, hopefully, everybody I'm calling on seems to be understanding that since this is a positive 2 here, that we can say that this is going to take us left 2. And since we have a -5 here, that means we're going to go down 5. Write your vertex real quick, so make sure we understand that part of it. All right, and Thalia, you have the disfortune or unfortunate fact that you're on my screen right now. So what do you think, Thalia?
-2, comma -5.
Good, perfect. So we went left 2, so now we're at -2, we went down 5, so we're at a -5. So I want you to do 2 things with that point. One, I want you to plot the point on the graph. So come over here to your graph, go to -2, so left -2, and then 1, 2, 3, 4, 5. So plot that point on your graph, the point -2, -5. So ultimately what we want to do is graph this. The other thing I want you to do with that vertex, so look at your table right now. Notice this middle row in your table. I want you to put the vertex in that row. Then what you're going to do is just now put the number directly in front of the -2, which would have been a -3 and then a -4. And we're just going to put these right in order now. So we're going to have -4, -3, -2, -1, 0. So whatever you get for your vertex, when we do these here in the future, we want that to be the middle point. And that's what the vertex really kind of gives us anyway. It's the middle of your parabola. That's why we're putting that in the middle of our table. What these directions also now tell you, we're going to create our graph. That's what we're in the process of doing, showing 2 symmetric points on each side. So we're going to talk about what that means now. So what I'm going to have you do first, go ahead and write the original equation. So x plus 2 squared minus that 5. What I'm going to now have you do, take this x value here of a -1. We want to plug the -1 in, and whatever that gives us is the y value at the -1. So we'll come down here, let x be a -1, and then we just want to evaluate that new expression. And that should give us our y value. So if I do a -1 plus 2, that should be a +1. And then we're going to square that and then take away 5. 1 take away 5 is a -4. So when I plugged in the x value of a -1, the corresponding y value that I just got was a -4. Plot that point now. So go to your graph, plot the point, -1, -4. All right, the next point that I'm going to have you plot is this -3 here. So take the -3 now and do the exact same thing. Take the original equation, if I can squeeze it in here, and let your x be the -3. Uh-oh. From there, just simplify this. We'll get a -1 squared minus a 5. -1 squared is a +1. Notice how we get the exact same value that we just got. So the point in front of and the point behind the vertex give us the same exact y value. They both give us a -4. That's not a coincidence, okay? And we'll talk a little bit more about that here in a minute. Let's plot that point. So -3, and then 1, 2, 3, 4. We didn't mention it in our transformations, but since this is a +1, this should be a parabola opening upwards. This is starting at, well, this does now start to look like we are going to be opening upwards, okay? So now, last thing, and then we're going to talk about how we can make this a little bit shorter. Take 0 and plug it in. So I'm going to erase these, so hopefully we've had time to copy all these out. I'll do this side since I did this first. Take your 0 and now plug it in. So take the original equation and plug the x value in as a 0. 0 plus 2 is 2, then we're going to square that. The 2 squared is 4. Take away a 5, and our y value should be a -1. So when I let my x be a 0, the corresponding y value that I just got was a -1. All right, last one, and then we can talk about how we can possibly make this a little bit quicker, because we don't want to have to do this for all of these. And the last value that we still have to plug in is the -4, okay? So take the original, let your x be the -4, just keep going through those steps, simplifying it to see what our y value is going to end up being. So the -4 and a 2 would make a -2. A -2 squared is a 4, and then take away a 5. This will also give us a -1. All right, so then now plot these two new points. So we still need to plot the -4, -1. So 1, 2, 3, 4, and then -1, and then 0, -1. If we knew going in that this was a parabola, which we would, and it's a parabola opening upwards, then we should like what we see. That should tell us that we probably graphed this correctly. So go ahead and now connect these points, draw in that parabola that's opening upwards, like so. And then we want to talk about a couple of things now we want to recognize. Notice how we did our vertex first here. Notice how the point directly in front and directly behind have the same exact y value. All right, that's not a coincidence. Notice how the point 2 in front and the point 2 behind also have the same exact y value of a -1. That's what we're referring to up here when we get two symmetric points. Because if you recall our axis of symmetry, so if I now draw in the axis of symmetry, if this point here and this point here are going to fold up on top of each other, don't they have to be the same distance away from the axis of symmetry? And then the same here. This point here and this point here. Notice how this is 1, 2 units away. This is 1, 2 units away. That's how we can graph these a little bit quicker, because whatever I'm going to get right here has to be the exact same thing I'm going to get right here. And whatever I get here, I'll make this a star, would have to be the same thing I'm going to get right here. They're symmetric. All right? So now, let's see if we really understood that. Let's go to this next problem. Let's write down our transformations real quick. This one's going to go downwards. So when we graph this, it better open down because we have the negative in front. The fact that we have a minus 3 means we're going to shift this thing right 3. And then this positive 8 tells us that we're going to shift it up 8. So with that info, write your vertex. And Gail, what do you think for our vertex there, bud?
Wouldn't it be positive 3, comma 8?
Good. Positive 3, positive 8. So go to your graph. 1, 2, 3. Plot the point 3, 8. So that should be up here. And then remember what we said. We also want to put that point in the middle of your table. So in that middle row, we're putting the vertex that he gave us, and that's the point 3, comma 8. On the left-hand side then, where you have all of your x's, we want to list all of our numbers in order now. So we're going to do 2, 1, 4, and 5. So we pretty much just go 1, 2, 3, 4, 5. What we just talked about are 2 points that are symmetric. Whatever I get for 4 here should be the exact same thing I get for 2. So we don't now have to do both of them. You pick one or the other. Whatever you get for the one, we know the other has to be the same. So I'm going to take this original equation, so the negative and then x minus a 3 squared plus an 8. I'm going to pick the 4. I'm going to plug it in and see what y value I get. So once that's plugged in, we would get a negative, and then inside the parentheses is a 1. Order of operations, we should square our 1 first. So the negative is still here, and then 1 squared is a 1. So this ends up becoming a negative 1 plus 8. So that y value is 7. So once we know that this is a 7 right here, then we also know we get a 7 right here. We don't have to plug in the 2. Let's plot those points then. So 2, 7, and then 4, 7, 2. I'm going to make my vertex a little bit smaller here. So it has the formation starting of a parabola that opens downwards. If we talk about our axis of symmetry cutting it through right now, notice how those 2 points are equidistant from the axis of symmetry. They're the same distance away. All right, so good stuff so far. And then the last thing we need to do is plug in either the 5 or the 1, because they're going to get the same value. So I'm going to pick 5. So let the x be a 5, add our 8. That 5 minus 3 would give us a 2 squared plus an 8. Also, if you have a calculator, the calculator is really smart. It knows order of operations. So you really could plug in this step right here. Just make it look just like this on your calculator, and it'll do all the work for you. Okay, if you're not confident in your order of operations stuff. This one would give you a negative, and then 2 squared is 4, plus our 8. So we would get a y value of 4. So when I plugged in 5, I get a y value of 4. But I know whatever I get right here, I should get the same thing right here. So I know that's got to be a 4 also. Plot those points. So 1, 4. And then 5, 4. We can draw our parabola in. And then notice how these 2 points are, again, the same distance away from our axis of symmetry, which is what it has to be. All right. All right, last one real quick. Number 8, some of you are still looking at this. Just write the vertex for number 8 and see if you know how to set up the beginning of your table. Let me pull it up. We all have 7, hopefully. And move it very slowly. There, you can see it there. You can see both of them. So look at number 8. Tell me what your vertex is. And then start the beginning of your table. All right, Victoria, I can see you. Is it Victoria or do you go by Vicky? You probably told me this already, but.
Victoria.
Okay. What do you think for our vertex, Victoria?
Okay, so -4 and 6.
Good. The positive 4 actually means our x coordinate's a -4, and then this positive 6 gives us a positive 6. All right, thank you, ma'am. And then we talked about how we want to put this in the middle of our table. So that's going to be the -4, 6. The left-hand column now we should be able to fill out very quickly. We're going to do -5, -6, and we're just really counting -6, -5, -4, -3, -2. That's the beginning of our table, so let's plot the point -4, 6. 1, 2, 3, 4. So that's our vertex. I'm going to do -3. I'm going to plug that in. But I know whatever I get for this value for the -3, I'm also going to get the exact same value for the -5. So I'm really getting 2 for 1. So we'll plug that in. Let your x be a -3. And then we just go through solving that. Or if you have a calculator, put it in just like it looks, and it'll spit it out for you. So the -3 and the 4 make a 1. No order of operations. 1 squared you do first. So you just get 2 times a 1. Then that's really just 2 plus 6, which is an 8. So if we know this is 8, we know that is an 8. And then the last one, we will actually finish on time, I think. I'm going to use the -2, knowing that whatever I get for a -2, I would also get for the -6. So -2 and the 4 make it 2. Square first, so that's going to give you 2 times 4 plus 6. We get 8 plus 6. Our y value for those 2 points should be 14. This should now be a parabola that opens upwards. We were kind of rushing to make sure we get to the new part. If you notice, this is now a 2, so this one should be a little more narrow than the previous couple that we have done. So when we go to graph this, I already have the vertex plotted. I'm going to do -3, 8. And then all I really need to do, think about our axis of symmetry cutting this in half. Even if we didn't do our table, notice how this point is 1 unit away. The other point would be 1 unit away on the other side of our line. And if we do -214, well, that's too big. Yeah, the -214 is a little bit too tall. It's way up here. The other one would be on the opposite side of your axis of symmetry at 14. And then we get a little more tight of a parabola squeezed in here. All right. Okay, after 3 days of this, we are finally done. So let me one more time. You've got 3 minutes. Let me just make sure we're all squared away where you're going for the homework. So you're going to submit it like you normally do. So underneath assignments, we're now in module 2, so you'll see that first. And then underneath module 2, this is 2.1. That's where you'll submit it. If you have the packet, then you can just go with the packet. If you don't have the packet and you do have a printer, or if you just need to use it on a scratch piece of paper, you can find it here. This is the homework PDF. This is the homework packet. So what you're doing was 1 through 12. So let me pull this up, and you're going to do problems 1 through 12. Just make sure you're doing it on 2.1. So it should start with these guys, and you're doing 1 through 12. I can't write on this for some reason unless I download it. Okay, clear with that? All right, you're inside 2 minutes. That's all I need to share. So unless you have a question, you're free to stick around if you want to, but if not, then we're all done here. Okay, have a good weekend. See everybody on Monday. Okay, we'll see you guys.
Have a good weekend.
I'm gonna kick you out, Alexis. I don't know if you can hear me or not.